Right. Just to continue from theorem 4, okay, after I made the last video, I noticed there were some things that I maybe forgot to mention. So let's just cover that in this video. So here again, we have a chord, right? So I didn't label them, but we have a chord, 2 points that on the circumference of a circle. And wherever they subtend towards, we know it's going to form the same angle. That was theorem 4. So um, if I have an angle that is created over there, let's see the angle as well. Wherever I create another one, so let's maybe do another one over here. All right, let's put the angle there as well. Angle, okay, let's put the angle there. Right, so you can see those two are the same thing. Okay, great. So that's what we noticed. Wherever this goes, all right, let's just move that. Wherever this goes is going to stay the same thing. So if those 2 points subtend any angles, right, it's going to be the same thing. That was theorem 4. That's not new. Okay, what I do want to point out though in this video, let's see, maybe I can get rid of some of these things. What I want to point out in this video. Right. This chord that we started out with, let's get rid of all that. This chord that we started out with, if we move that chord, or so let me just get rid of this chord, not the chord, the let's get rid of all of these other things, even the angle there. If I move this chord now, with the app, it's not too as easy as just keeping it the same length and putting it somewhere else because the chord length changed. But if I take that same chord and let's say, for example, that I kept it the same length, unfortunately I couldn't keep it the same length there, but if I did keep it the same length, then wherever that chord goes to form an angle, it is going to be the same angle. Okay, so what I'm saying, okay, maybe we should see if we can do it for ourselves. What I'm saying is this: if I have a chord over here and this chord length is maybe 5 centimeters, right? Let's say that that length is 5 centimeters. Right, let's call it AB, and let's say AB is 5 centimeters. And if AB subtends, they go together to form this point over here. It has a certain angle, right? And we know if AB subtends over here, that angle is going to be the same thing. That is what we know from the theorem. But what I'm adding today is I'm saying that if AB goes and it's somewhere else, so let's say that there's another 2 points over here. Let's maybe even say that AB and AB moved from here, it's no longer there, it went to this new point over here, so it all got the same length, so that length is still 5, right? Then wherever that subtends towards is also going to be whatever that angle was. So whatever this one subtends towards, that angle and the angle that we see over there, they are the same thing. Why are they the same thing? Because we have the same length chord. Okay, so I call them both A, B, but rightly the second one could have been called something else. Maybe C, D, doesn't matter. But if the chord length is the same thing, the angle subtended will be the same thing. That is still theorem 4, right? So we can, instead of, last time we said that it was angles in the same segment, we could also say equal chords, equal angles. Right, you don't have to always write the words out. So we can say equal chords, equal angles. That's still the same theorem. Okay, that was something that I wanted to mention. And then there was another thing that I wanted to mention with us as well. So let's just go back to our drawing over here. Let's take these points and let's. Right, that's not what I wanted. Let's get rid of that. All right, so I'm going to take these same points and then I'm going to subtend another angle over here. So we know that these two angles are going to be the same thing. Right, this one's also going to be 30.1. Right, so what I want to show you now is if I take my circle, all right, I want to select the circle and I'm going to go hide the circle. Okay, so if you don't have the circle there and you only have a shape that looks like this, right, and you can see that angles formed are the same thing, then you know that there is a circle that exists around there. Okay, so what I'm saying with the second part is if you have 2 points and they subtend an angle that's there and they subtend another angle that's there. And these angles that we have here are equal. If those two angles are equal, then we should know that there is a circle that exists around that shape over there. Okay, so that would be the converse of our theorem. Okay, so our theorem is this circle, 2 points, subtend an angle, right? These are the same. That's what our theorem says. The converse is if we have 2 points subtending an angle and those angles are the same, then there would be a circle that goes all around them, right? Those are the comments that I want to add to theorem 4.